tool. In the tool, you will explore the distribution of data values, visualize the distributions using histogram plots, and then implement a data prep flow to create a new feature based on an average number of taxi rides per hour in a rolling time window. Finally, you will deploy and run the data prep flow on GCP and monitor the job execution using Dataflow. Let's take a closer look. Okay, to get started with this lab, you need to prepare some prerequisites. You begin at the Google Cloud Platform dashboard. First, you will need a Google Cloud Storage bucket. You can create one if you go into the Products and Services menu, which you can access by clicking on the hamburger icon. Scroll down to Storage, Browser, and click on Create Bucket. As you can see from the guidance on the screen, the name of the storage bucket must be globally unique. Here, I have set up a unique bucket name in the US East 4 location. Shortly after I click Create, I can see that the bucket with the unique name is ready. The next thing that you need to prepare for this lab is the BigQuery dataset. You can find BigQuery back in the Products and Services menu under the Big Data section. And when you click on BigQuery, you should see a new tab open in your browser. To the right of your project name, click on the down arrow and choose Create New Dataset. Use the name Taxicab Reporting for the dataset and click OK to create it. Once the dataset is ready, you need to go back to the Google Cloud Platform dashboard. From there, navigate to the Data Prep link in the Products and Services menu. Since Cloud Data Prep is a service from a Google partner, you need to accept a new set of terms and conditions. Click Accept to do that. Also, you need to click Allow to let Trifacta, which is Google's partner that developed Data Prep, to access your data. When you click Allow, it'll take a few moments to enable Data Prep for your project. So right now, you can see the video fast forwarding through the wait. Next, you need to choose the account to use for Cloud Data Prep and allow Data Prep to access your projects. When you're setting up Data Prep on your project for the first time, you need to specify the storage bucket that will hold your data. Here you can see that the bucket created in the beginning of this lab is used to set up Data Prep. Once the bucket is selected, click Continue. Once Data Prep is set up, you can dismiss the help tutorial by clicking Don't Show Any Helpers. Next, you'll use Data Prep to create a new flow. Let's call this flow NYC Taxi Reporting. The flow is going to show a process for ingesting, transforming, and analyzing taxi data. Go ahead and click Create. The first thing you need to do in order to create a flow is to add some data sets for the flow to process. In this case, you will import some predefined data sets that our team already saved to a public cloud storage bucket, and you can access the storage bucket using the name ASL ML Immersion under the NYC Taxicab directory. The directory has a few files. You will use the files with the 2015 and 2016 taxi fare data. Notice that these are comma-separated values, CSV files. Click Import, and shortly, you will see the two files added to your flow. To implement data processing or wrangling for these datasets, you will need to add a new recipe. Next, you will add steps to this recipe. Once the dataset is loaded, you'll see a preview of a sample of the data from the dataset. Here, for example, you can see that the dataset includes information about taxi rides, such as pickup date time, drop-off date time, and the number of passengers in the taxi. Also, notice from the trip distance histogram that most of the trips were under 5 miles in distance. Next, you'll go ahead and union 2015 and 2016 datasets so you can work with more rows of data. Once you select the 2016 dataset, you need to click on Add and Align by Name, which will make sure that the names that have the corresponding column headers are aligned to the union version of the dataset. Add the union step to the recipe, and after Data Prep previews the union, you'll see a sample of the dataset that includes taxi rides for 2015 and 2016. Notice that the data about the pickup date and pickup date time is in different columns. Since this lab will show you how to compute the rolling averages for taxi fare amounts, first you need to convert the input data to the SQL date time format. For that, you can add a merge to the recipe, which will concatenate values from multiple columns. In this case, the columns are called the pickup date and the pickup time. Use pickup date time as the new column name. Also, go ahead and use a single space as the delimiter between values. Notice that on the left, you now have a preview of the new column. Next, create a new derived column that will convert pickup time into a SQL datetime format. Once the new datetime stamp field is available, you will extract out just the year, month, date, and the hour information, without the details of the minutes and seconds. Since the hour pickup datetime column is missing the values for minutes and seconds, it's not parsable as SQL datetime format. So you need to create a new column that can be converted into a valid SQL datetime value. To do that, you will create a new merge operation, and you will use the merge wrangler again. This wrangler will concatenate values of the hour pickup date and time column with a string that contains 4 zero characters for the values of the minutes and seconds. Notice that when you add a new column, it will get an automatically generated name like column 1. You can easily rename that. In this case, you can rename it to a pickup hour. Next, you will compute some statistics based on the pickup hour values. You can use standard SQL statistical aggregation functions like sum or average. You can see that this wrangler will compute the sums and averages for passenger counts, and the same combination of the sum and average for the trip distance and fare amount. Lastly, it will compute the maximum fare amount for each pickup hour. Just as earlier, notice that you get a preview of the results for the computed statistics in the histograms on the left-hand side of the screen. Also, if you observe the average fare amount in the histograms, most of the average fares are in the range from $18 to $19 per trip. Next, you will go ahead and compute the rolling average for the fare amount by looking at the trailing 3 hours worth of data for each pickup hour. You can compute this using the rolling average function in Cloud Dataprep. Here are the values for the rolling average, assorted by the pickup hour. Finally, name this column Average 3-Hour Rolling Fare. Alright, once the recipe is ready, you can deploy the recipe as a Google Cloud Dataflow job. To do that, you need to click on Run Job and specify where the results of the jobs are going to be published, or in other words, stored. By default, the results of the job are saved as CSV file in Google Cloud Storage. Instead of doing that, you can change the destination to be BigQuery, and you can create a new table in BigQuery every time the job is executed. So, if you change the selection on the right to create a new table at every run, and rename the table to TLC Yellow Trips Reporting, you will get a new table in the NYC Taxi Reporting dataset. Remember, this is the dataset that you created in the beginning of this lab. Go ahead and run the job. Once the job is shown as transforming, dataprep will begin to deploy the job to Dataflow. This usually takes a few moments. You can monitor the progress of the job from the job session of the dataprep menu if you click on the ellipsis symbol on the right. The ellipsis menu will not have the link to the Dataflow job right away after you deploy the job, but if you wait a few moments and refresh the page, you'll find that the menu gets updated and you'll see a link to access the Dataflow job. If you click the link, you'll be automatically taken to the Dataflow user interface, where you can monitor the detailed transformation steps in Dataflow as created by dataprep. On the right-hand side of the Dataflow UI, you can get details about this job execution. Here, you can see that since the job has just started, the Dataflow cluster to run this job still needs to be scaled. However, you can already monitor the results of the job configuration. Here, none of the individual transformation steps of the job have started, except the few that are preparing the table in BigQuery and are just starting out to fetch data from the input CSV files from Google Cloud Storage. In addition to monitoring this job from Dataflow, you can navigate to BigQuery and monitor the output of the job in your taxicab reporting dataset. As you recall, once the job starts running, it will insert values into a new TLC Yellow Trip reporting table. Since it takes a while for the table to be created, you may need to wait and refresh the page to see the update. Once the table is in place, you can enter a SQL statement to fetch results from the table. However, make sure you have your SQL dialect configured properly before you run it. Here, you can see that running the job generates roughly 192 kilobytes of data, including information about the pickup hours, average trip distances, average fare, and the other information computed by Dataflow. Okay, this is it for this lab.